Looks like Twitch thinks we're live. It says live at least. It's giving me more spinny bars. So I'm going to go ahead and post some comments saying that I'm streaming. Streaming indie dev. Gonna try to make this ship look nicer. Shader stuff! Exclamation point. No, that's not what I wanted to do. Alright. Kinda wore out my voice yesterday, sorry. But I should still be able to program. So, today what we're... Alboetchi's already here. Today what we're gonna try... Oh jeez, my voice is really ragged. There was a rally yesterday. And there was a lot of shouting. Anyway, I'm gonna try and make this look a little bit nicer. One of the things that I noticed when looking back on the screenshots of the just the older work I did with the Galactic Line, the ships looked really nice. And the reason they looked really nice is because I spent a crap ton of time making them look really nice. And I think it would make sense if I were to do the same thing here. So what we're going to do is replicate some of the things that we were doing. In the old version, what we would do is we would modify the meshes with mesh colors. However, the old meshes also had a lot of details built into them. So basically, I relied on a combination of greebles and a mesh fade, a color fade on the meshes. But in this case, I think I'm going to try and go for simpler parts, as I talked about. And that means that I will want to apply the textures, the greebling, separately. So we might as well make a shader to do both the greebling and the color fade. Let's go ahead and do that. Oh, I bit my cheek yesterday too. Well. So what we're going to want to do is create a new shader. I think I want a standard surface shader. I certainly don't want an unlit or image effect shader. I'm not sure. Compute shaders are something I'm not real familiar with. So we'll call this the ship greebler. And the ship greebler will be responsible for making the ship greeble. I know that was a complicated idea. Not really, Alboetchi. As expected, only a couple dozen bad guys showed up and about 15,000 counter-protesters. So it was mostly, unless you were like right up against the fence, it was mostly like a festival feeling. But then right after that, I went to the Midnight Festival, and that was just as loud. So let's go ahead and open up the this shader and the older shader, because the older shader actually has some stuff in it, and I don't have this memorized, so I have to remember it, reorient myself. It's been a couple of weeks since I worked on shaders. So what we're going to be doing is, first we're going to want to try to get the color fade to work. In order to do that, we have to know what colors we would like to fade towards and where. So for that, we're going to want to try and decide about how we're going to represent colors in this game, because in the other version, what we do is we recolor the meshes based on nearby color augment objects like engines. If we're not going to be recoloring the meshes that way, we have to still have those color augment meshes. And to be honest, I don't believe there's a good way to do that here. I can do it with a global variable, but then every color augment object in the game, in the scene, would be present for every single attempt to run through this. And that means that it would end up being like if you had 8 ships, then every ship would be loading every other ship's color augments. which seems like it might be pointless. I can do a basic color fade without the color augments, but I think the color augments really add a lot. So maybe this will just be a texture thing. But with that said, the Ship Greebler still has to allow for the vertex color to matter if we're going to be doing it the old-fashioned way using mesh clones with vert colors. Because we have to use vert colors, we're going to need to mix that in here. I think what we're going to want to do is mix that into the input, but I don't happen to have that memorized. So I think we're going to have to open up a bookmark of surface shader stuff. I've got like 3 or 4 bookmarks and I have no idea which one of these is correct. I mean, they're all correct. Which one of these is applicable? So there is a color input. I don't know whether or not color is a vert color or a or some kind of specified color. I think it might just be correct. Let's try it. So it would be float 4 color, right? Like that. Not sure. So according to this, there's some surface output stuff, but none of that is relevant right now. Vert final color. Input structure. Here it is. Aha, per vertex color. Yeah, this is correct. Color semantic. That's good. Okay, so that was correct. I just randomly found it, and it was correct. Hooray! So, with that in mind, we also have an underscore color, so that's not a fantastic way to distinguish them, but that's fine. We'll go ahead and just multiply this by in.color as well. And that should allow us to get a nice proper color fade if we use our meshes. We'll have to duplicate every single mesh and have custom colors on them. That means that the ships won't be as efficient. But to be honest, having them look nice is an extremely important task. I think it's okay if they're a little less efficient. Later on, if it turns out they're too inefficient, I can try to figure out a way to bring them back. But here's the thing. If I start to rely heavily on meshes with shape keys or armatures, they're not going to be batchable anyway, so I might as well make them color distinct. The only savings I'll get is with absolutely stock meshes. And one of the big selling points here is that you can, like this, warp the hell out of these meshes so they fit into your schema. When you do that, it's a new mesh, so I might as well make that new mesh the mesh in question here. Excuse me. So, with that in mind, we still have a couple of things to do. We're going to change the hull shader to our newest favorite Ship Greebler. And the highlight will also be changed to our newest Ship Greebler. We've got this warning, but I think I might leave the warning as a different kind of material. Well, we'll work on that later, I guess. But for now, just this is fine. And you can see that nothing changed. That's because all of the meshes have a color of white, 1111. And when you multiply your output by 1, nothing happens. So now what we need to do is to create the ship fade utility. We already have it, but it's also, we have it in the old version, but it's also something that's really easy to program. I'm not sure if I want to try and import it or just reprogram it. I think we'll go ahead and just reprogram it because the import will carry along a lot of random stuff here. So we'll go ahead and create some graphics scripts in our graphics script library. create C# script mesh fader. The other option here is we can use vertex color to talk about what kind of greebling we want to do. But we're not using the ship UVs. So all of these UV maps are empty, and it would make more sense to use the UV for that. So what we may end up doing is using the UV as a second set of parameters that we fill in during this faded system where we can have it greeble at different rates. For now, however, we're going to go ahead and think about that in a little while. Right now, we're going to focus on changing the mesh color. So in order to change the mesh color, we need a list of all of the meshes that we need to change, and then we need to change them. Obviously, this is fairly straightforward, so we're going to go ahead and just start that up here. So public void fade all meshes. And then we'll do public void fade mesh, mesh. And obviously the main goal of fade all meshes is to get all the meshes. So mesh list, mesh filters equals get components in children mesh filter. And I don't know whether we want this to be true or false, but I think we want it to be false so that interiors aren't affected. We're not planning on using interiors in this particular version, though, so maybe it doesn't matter. Either way, it should be fine. For each mesh filter MF in MFS, fade mesh MF.mesh. So here's the thing. We have to decide public void fade mesh filter. There we are. We have to decide what mesh we're going to fade here. But there is one more thing. The mesh filter is not the only kind of mesh filter there is. I believe there is a different mesh filter for... maybe not. I thought there was a skinned mesh filter. But I guess it's just the skinned mesh renderer is different. There's no skinned mesh filter. That's fine. We need to decide what mesh we're going to use here. Now, we're going to be cloning the mesh in most cases, but in cases where the mesh has already been created as a distinct object, there's no reason to clone it. We might as well just use that already distinct mesh. Now, the reason that we might have meshes that are already distinct, there's a lot of reasons, but the big one is that we're using some morphs on these, and every time we use a morph, we have to make that mesh unique. We don't want to make it unique again. There's no point. So we'll go ahead and say if mesh filter dot mesh equals mesh filter dot shared mesh, then we'll want to create a new mesh. Mesh equals mesh filter dot mesh dot clone. There's no clone. I thought there was a clone. I guess the closest thing to a clone we've got is the combined meshes, but that's really awkward, combining one mesh. I thought there was an easier way to clone this than to like manually type in all the cloning stuff. A Unity mesh clone. How do I clone a mesh? How do I duplicate a mesh asset? This guy is not asking the same question I'm asking. Okay, so you can actually use mesh instantiate. Okay, so let's try this out. Mesh.instantiate. Yeah, there we are. That'll do just fine. Mesh filter dot shared mesh. Any other arguments? Nope. Okay, that's fine. Close, close. There we are. According to the docs, the first query of meshfilter.mesh returns a copy of the mesh, and subsequent calls return a reference to that copy. Yeah, that's a good point. So I guess we might as well just say that mesh equals mesh. Because I mean, this will work, right? Mesh equals meshfilter.mesh. If that's true, if the docs are correct, then this will work fine. We can just fade mesh the meshfilter.mesh because it will automatically create a clone of the shared mesh if there isn't one, or if there already was a clone created, it will just continue to send us that clone. So that should work, right? If Supafcan is to be believed. You are to be believed, right? You're not faking us out. All right. So what we need is to fade to various colors over the course of the ship. And for that, what we're going to do is we're going to go ahead and just have 2 colors, nose color, mid color, and that's 3 colors, but that's fine. That should allow us to get a couple of different colors for our ship, and we can change this on the fly to be, you know, a little bit nicer. We'll just go ahead and make them really aggressive to start with, just so that we know that they're happening. And what we're going to want to do here is use our mesh. We're going to go ahead and just override all of the mesh colors with new colors. And our colors are going to be based on where this object is in the ship object. We're not going to be using the mesh's local space coordinates. We're going to be adding those local space coordinates to the object. So vector 3 verts equals mesh dot verts. I know there's a get verts. This is a little bit faster because I can pass it a list of verts, and that keeps it from allocating. I think that's probably for the best in this case, for a lot of reasons. Mesh.getVerts, and it looks like we just pass it the list that we would like it to get, and then at the end at the beginning we're going to clear it vertcache.clear, because I think it will just add rather than clear and then add. Now this should avoid a memory alloc. We still have at least one memory alloc here in the colors. We could use a list for these as well, and I actually think we have to. Last time I checked, the color system wouldn't take an array of colors. It would only take a list of colors. So that's what we'll do. Mesh.getColors, yeah. Color cache. What's the other option though? Oh, so just 2 different kinds of colors, that's fine. Color cache.clear, and there we go. So this gets us a list of the existing colors. We don't actually need a list of the existing colors, but in this case, yeah, there's no reason to get them. We'll just clear it. And then what we'll do is we will go through all of the verts. So for each vector 3 v, I guess we'll just do it for int a. 0a is less than vertcache, mesh.vertCount, which is actually cheaper than counting the list by a considerable amount. Normally I don't optimize quite so aggressively, but this is something that needs to happen in less than a frame. So there's already a lot of overhead in just writing to the meshes. I need to keep this as spare as possible. So then we'll go ahead and put in a vector3 vert. Vert equals mesh, equals vert cache A. And then we'll want to add our ship's offset to that. Add its local space to the... Okay, hold on. I made a mistake. Because I need to know the mesh filter, I can't just have the mesh. That was something I was doing because I thought there were different kinds of mesh filters for some reason, but I don't need that, and we're not going to want to use it. So instead, we're going to use transform local equals mesh filter dot transform dot position. So here's the annoying thing. I actually need to subtract the parent's position, but the problem with this is that doesn't take into account any scaling that might be happening within the object, or any rotation for that matter. So really what I need to do is continually transform these verts through those transforms, which is not an inconsiderable cost, but we'll give it a shot. We'll see how slow it is. We can all optimize it later if we need to. So if we do this local to world matrix, we could get the absolute matrix that we would need, and that would be a little bit faster. But let's do it. Let's do it with this. I think they might have optimized this. There were some problems with how slow this was in the olden days, but we're going to want to use transform point vert. But the thing is that that'll transform it into a world coordinate. What we needed is a ship local coordinate. So what we need to do is transform dot inverse transform point local dot transform point. So we convert it into world space, and then we can convert it back, and you can see why this is annoying. Now, in the past, what I did is I simply put the ship at 0, 0, 0 while doing this operation, and I think that's what we're going to want to do here. So vector3 pos equals transform.position. Transform.position equals vector3.0, and then down here we can say transform.position equals why is that highlighted differently? Whatever. Save us a set of inverse transforms per point. So because of that, we won't have to do this. Although, if our ship is scaled or rotated, we do. Okay, so hold on. Quaternion rod equals transform.rotation. Transform.rotation equals quaternion.identity. And then down here, transform.rotation equals rot. This is not very, I mean, it seems clumsy. There's probably a better way to do this, but basically I need to make it so that the ship's coordinates no longer matter, and that every single world coordinate for these objects is ship local. So I need to make the world space and the ship space line up. There's still no scaling involved, though. We might as well go ahead and put the scaling in. The problem with the scaling is that there's not really a good way to set the scale. I think we'll just assume that the ship object itself is never going to be scaled. There's not really any reason to scale the ship object, as far as I know. But that's fine. So we're going to go and grab the global position of each vert, and then what we're going to want to do is translate that global position into a color variant. And to do that, we have to understand which direction is forward and what the bounds are. But for now, we're going to try and do it as simply as possible by simply lerping between the color sets depending on the Y value, maybe the Z value, Y value. So color 32 call equals color 32.lerp. Yay. And we're going to want to give it a nose color and a mid color and then a distance. So vert.y. Here we'll say if vert.y is greater than 0, then call equals that. If vert.y else, the opposite. And then at the end, we're going to want to assign those colors back to the mesh. And then we're going to want to make sure that, I think that we don't need to reset anything else. I think that will just work. But we actually have to call it, so we're going to go ahead and add in a menu item. Yep, wrong button. There we are. All right, well, that was not exactly fun, but we're ready to rock. Let's try it on for some size here. Poof. Pause this, and then we'll try it out. Boom. Nothing happened. Now the question is, did nothing happen, or did I just not set up the shader correctly? Well, let's go ahead and put in some debugs. Debug.log mesh filter.name fading. It's possible that I also need to run a mesh.setDirty or something similar to tell it, but that shouldn't be the case because it's got the set. I'm not setting it I'm not setting a value. I'm calling a function to set the value. So should already have the set dirty in there. The other option is I may have to set the mesh back to the mesh. Yeah, it looks like that's what I've got to do, which is kind of dumb because I don't know why that would be different. Mesh filter dot mesh equals mesh. No. So it should be working, but I'm not seeing any. So here is the cloned mesh. There's no way to tell whether it's got any colors attached to it, unfortunately. But they shouldn't all be white. That's for sure. Well, let's go ahead and do this a little bit more easily. Here on this fuel tank, we've got another fuel tank here. We'll drop one inside the other, and then we'll just add a fader right here. And that way we'll be able to do these with a lot more detail without flooding our screen. So debug.logvert. And hopefully that will keep it down to just a couple hundred lines of log rather than thousands and thousands. Oh, I'm just a fucking idiot. Okay. Never mind, everybody. I found the problem. Let's go ahead and take this out. So, there. See it? What we've got here is a bunch of meshes. The logging is what's taking up the time here. I can just take it out now that I know it works. I think there are still some problems with it because I saw something that looked suspiciously like these are all just backwards. That's the problem. Okay, so what we're going to want to do is grab this ship and ask it what's going on. So you can see that what happened here is that our y coordinate is not the same as that guy over there. Here, our y coordinate ended up being the wrong fade. We may as well go ahead and make that a value, public vector 3 axis. Yeah, I guess this is fine. We don't even have to transmute that axis because we are in world space when we do this. But what we're going to need to do is change this vert.y into a multiplied value. And that's going to be vector 3 dot axis comma vert. This will figure out how aligned we are, and that will give us a float value, which will tell us how on axis this is, but only if these are, well, no, that's not what we want at all. We want to, you know, I can't think of a fast way to do this. I can think of a bunch of slow ways, but I can't think of a fast way. So maybe we'll just hard code it to use Z instead. Oh, I could just multiply. Hold on. I'm just an idiot. Of course that's easy. So what I can do is I can multiply axis and vert together. I just don't know whether or not that's allowed. No. So there's probably a function for that. Ortho normalize. I don't see a function for it, so I guess we'll just do it manually. So vert.x equals times equals axis.x, vert.y times equals axis.y, and vert.z times equals axis.z. Float val equals vert.magnitude. But we need to check and see whether or not any of those values are negative. So if vert.x is less than 0, or vert.y is less than 0, or vert.z is less than 0, val times equals -1. And then down here, we'll just use val. And in a moment, what we will do is change val out to be scaled by the size of the ship. And that should work pretty well. By the way, the reason I keep hitting play is just so that I don't end up with any stupid stuff happening in edit mode, because edit mode is a lot more fragile. So here you can see it. This is the basic idea. We got a rear color in the back, and we got then blue here, and then we got white here. Right now, it's fading over the length of 1 meter to each side of 0, which is obviously very, very small. What we're going to need is to have bounding boxes which tell us what our overall bounding box is. So protected bounds, overall bounds. Here in fade all meshes, what we're going to want to do is go through, grab all of the bounding elements, and then add them together. The question is, I think that these actually have bounds. I guess not. It must be the mesh renderer that has bounds. But we're just going to go ahead and use the collision boxes. There's not really any other reason, you know, no reason to be any more interesting here. And then we'll do collision, collider. Collider array C's equals get components in children, colliders. And then we'll go ahead and say for each CS, for each collider C and CS, overall bounds dot encapsulate C dot bounds. This should work because the bounds are not grounded around 0, 0, 0, or rather the ship is grounded on 0, 0, 0, so there's no chance of accidentally including 0, 0, 0 when we don't need it. 0, 0, 0 will be something we always need anyway. And because we have these overall bounds, we know roughly how long the ship is supposed to be. So vector3 bounds equals overall bounds dot extents. So this is half the size. The problem is that we need to offset, well, I guess it doesn't matter. So we're gonna want to multiply the bounds elements by the same things. So bounds.x times equals axis.x, bounds.y times equals axis.y, and bounds.z times equals axis.z. I'm trying to think of the best way to do this. I think we just want to divide by these, don't we? Vert divided by equals bounds, right? Can I divide by a vector 3? Or I have to do it all again, don't I? Axis.x divided by bounds.x, axis.y divided by bounds.y, and axis.z divided by bounds.z. Now the problem is that this is not very good for one reason. We're assuming that the center of the bounds is at the center of the ship. If the bounds are not centered, then that means that we're going to have drift. And that drift is something we can fix by adding in an arbitrary value here. That should work. It might be minus center. Well, we'll know soon enough. I got a shadow in the way. That's fine. Okay, so let's pull this thing out of the shade and take a look. What we've got is a fairly good indication of what's going on. You can see how it's red in the back, and then it fades to blue, and then it fades to white. But our little army here doesn't seem to be affected. And why is that? Because the skin to mesh renderer doesn't have any mesh filters at all. So it looks like we have to look for the skin to mesh renderers separate from the mesh filters. Which means that we do need to do this based on a mesh. So we're going to go ahead and public void fade mesh. I was right. My weird memory was correct. There is more than one kind of mesh filter. It's just the other kind isn't even called a mesh filter. So fade mesh. Oh wait, we need to be able to set this back up. So mesh filter.mesh equals fade mesh, mesh filter.mesh, mesh filter.transform. There we are. And this will have to return a mesh so that we can properly do this. So return mesh. Oh, we don't have to set mesh filter.mesh. We can just fade the mesh. Okay, that's fine. We'll return it anyway just because I guess that's a good practice. What we're going to need is a public void fade mesh skinned mesh renderer. Mesh renderer. Fade mesh. Mesh renderer. Dot mesh. No? Dot. Oh, it's capitalized. Mesh renderer. Dot mesh. Okay, so the shared mesh is the thing that's happening here. We're going to have to create a cloned version of the shared mesh and then reassign it. There's not really any other option, so that's fine. Mesh clone equals mesh renderer equals mesh.instantiate mesh renderer dot shared mesh. And then here we'll go ahead and say fade mesh clone, but we'll say mesh renderer dot shared mesh equals that. There, that should work. We just have to make sure that we actually grab all of those skinned mesh renderers. Get components in children, skinned mesh renderer, false. For each skinned mesh renderer, SMR in SMRS, fade mesh, SMR. What have you got for us? Bugs. Okay. Cannot convert mesh to type mesh filter. Did I screw this up? Is this a shared mesh not? It's a mesh. What's going on here? The best overloaded method for fade mesh has some invalid arguments. Oh, because I'm not passing it the transform. Idiot. Perfect. The only thing left is this guy, which is right here. We're going to go ahead and just say that this is called local rather than parent. And I think that's fine. I don't think that there's anything else that's going to be bothering us. Let's give it a shot. So now our arm should also get nicely faded. Boom. Aha, see? Of course, the difficulty now is that our arm is a huge bounding box, and that means that we don't really have much of a nose color here. It is pretty strictly mid-body color. To be honest, what we really want to do is change the values so that mid-body isn't quite so far forward. Just because nose actually should take up the front half of the ship. So what we'll do here is we'll say val times equals 1.5. This will get us a value between negative 1.5 and 1.5. We can say val plus equals 1 or plus equals 0.5. And that'll get us a value between negative 1 and 2. That will move our 0 point back to 1/3 rather than 1/2 of the body of the ship. That should allow us to get a slightly better look to most ships. Later on, we can make this an anim if we would like, an anim curve. I think that's actually what I originally did. But in this case, I'm not too concerned about it. We'll deal with it later. Because there's still one more thing that we have to do, and that is the color overrides. So create C# script color overrider. And this color override system is something we put on engines most of the time to allow us to get like a burnt black look. So we'll do exactly that. The problem with the color overrider in this case is that these engines are cereal box shaped. And what that means is that the color overrider may not be where we think it is, because the center of these meshes in terms of their pivot is way back here rather than at the tips. So the color overrider shouldn't be here after all. Instead, the color overrider needs to be on something that's at the tip. As it turns out, there's loads of things at the tip. All of these particle systems are at the tip. So we'll go ahead and put in a color overrider on this particle system. We'll do the same here. And what we're going to want to do is actually edit that color overrider so that it exists. We don't need a start or an update, but we do need a color. Public color 32 override color. We'll go ahead and make that color.black. Later on we can change it. That should be all we need in order to make that work, but we're also going to want a public float range, and we'll make that 10 by default. So when we have that, what we end up with is an inability to quickly darken our system. Now, as I recall in the past, what I did is I actually used the alpha to override metallicity, or something similar, but I don't think we're going to need that for a variety of reasons. So let's go ahead and try to get this to work without it. What we're going to need is a list of all of the color objects. So protected color overrider, overriders. And then here we'll say overriders equals get components in children overriders. And I think we can go ahead and get all of them this time. We don't need just the ones that are active, because otherwise there are times when we might use an inactive object as a marker. Boop, boop. There we go. So those are going to be what we use to get a list of all of the color overriders. The problem is that we need to apply overriders to these meshes. Cycling through every color overrider is probably going to end up being quite slow. So what we'll do is we will just create a list of overriders for this specific mesh. So list color overrider appliables. So here we'll say appliables dot clear. Actually, I'm not actually sure that this is going to work out, because I don't have the bounds for this mesh. So we'll just go through and we'll walk through all of them. If we get so many color overriders that we end up slowing down, we will have to deal with it. So we grab all these colors, and then we're also going to want to grab the color overriders. So for each color overrider, I guess for each is for int b equals 0, b is less than color overriders, length b++, color overrider, co equals color overriders b. And what we're going to want to do is make sure that we are within range of it. So float delta equals co dot transform dot position minus vert. Now that I think about this, we're going to have to put this much earlier because vert is being morphed. There. So, and actually, this actually goes afterwards. So, all right. So, use the real position to determine color override. Then we'll say float override level equals 0 and color 32 override color. Make this colored up black for now. We'll go ahead and just set it up as any given color. Since we already have the mid color as a value, we'll set it up as that. Just I don't want to risk accidentally getting a transparent color in there that I don't want. So what we're going to want to do here is we grab the delta as the transform position minus the vert position dot magnitude divided by the overrider dot range. And that range will be like 10. So if you're within a magnitude of 10, then you'll see that this, goes from 0 to 1. The delta is from 0 on up, but in actuality, the opposite is the level of lerp we want. So here we're going to go ahead and make this into a 1. And we're going to only use this if the delta is less than 1. So if delta is less than override level, then override level. Did I spell override level wrong? No, it's just not taking for some reason. And override color equals co.color. So what is barfing here so I can actually get this to keep filling stuff in correctly? Nope. Nothing's barfing. It just was being ornery. That's fine too. So here we're going to go ahead and say that call if override level is less than 1, call equals color32.lerp, and then we'll want to use the override color, and then the override level. Boom. And that should allow us to have nice overrides. However, at the moment, those overrides have a soft edge, meaning that they won't, well, they won't be like a hard ring. They'll be like just a fluff. And that might be what we want, but later on we may want to square the distance or something similar to give it a little bit of a stronger feel. But you can see that here. You can see how it goes back to this burgundy red, and then right at these, it turns to this pitch black color. The engines actually have a different thing in them, which is changing that one material's color. How come I can't rotate this? Because it wasn't selected, you idiot. There we are. I'm just turning this up so we can see it a little bit better. These bright red rings are a separate material that is supposed to glow, and it is glowing. But you can see how the area in here is now pitch black. It's been made quite dark by the, you know, the burning of the engines. And that's kind of the point. We want this to feel like it is interesting like that. We'd like it to have some colors that really set this up as a unique vessel. Now, with that in mind, let's go ahead and do it one more time and then adjust it so that it actually looks decent. Boom. So this is what it looks like right now. The problem is that those are obviously A, terrible colors, and B, the ship itself doesn't feel real. It feels still quite fake. Part of that is the lack of greebles, but a big part of that is also the fact that this material doesn't properly catch the light. It looks like, it doesn't even look like plastic. It just looks fake. So what we're going to want to do here is transform some of these materials to look a little bit better. So you can see that what we're getting here is a variety of possible results. Once we have a skybox, we can get theoretically some reflected sky, but here's the problem. This is supposed to be a very bright material. The more reflected skybox we have, well, the reflected skybox is going to be mostly dark stars. So the more metallic this is, the darker it's going to be. The smoother it is, we get these smoothing values here, but that's not going to help us for most of the ship's lighting situation. So I'm not sure how much that's going to matter. I think we might need some other... How can I make this feel more realistic? We're going to use some texturing, some splats, to try and make this feel a little bit different. But right now that doesn't exist, and I don't have any textures ready. How can I make this feel a little bit better? Part of it is the fact that this is a custom material and we no longer have all of these values. For example, there's no height map or anything here. We're not going to be using any of that. But in the old thing, I think I used some detail meshes and some stuff like that, and that's just no longer here. The other thing that this has that our objects don't have is the ability to turn off reflections and specular highlights. To be honest, I don't like how the specular highlights look on most of the ship, but I guess it doesn't matter that I've got to turn them. Yeah, this should be fine. This should be fine. The problem is it still looks pretty bad. I think I really need to put the texturing in, and I just don't have a texture here. I can always drag a texture in from another project. Or I could make a new texture. I'm thinking of the older projects. They have these tiled textures, and that's not really what I want. To do the greebling, what I'm going to want to have is some textures that I can apply at various opacities that will include normal map, metallicity, and values like those. It's not about overriding the color. I might have some color override stuff in there, but that's not the primary focus. So the texture I create isn't going to be an RGBA texture with RGBA standing for the things it's supposed to stand for. It's going to be like R is a metallicity element and G is a color fade element and that sort of stuff. And that's going to make it a little bit hard to use any kind of pre-set up parameters. But let's go ahead and just use an arbitrary texture just so that we can get something going to start with. How about some sand? That's fine. We'll use some sand. So you can see that what we've got here is a very yellow texture now, and it looks like the shininess values are too high on the hull here. We'll go ahead and But this sand is not going to be what we use. You can see that these have a sand texture now being properly applied to them, but these do not. And the reason for that is quite simple. These don't have a UV coordinate system. I'm not using the UV system that is built in. If we pop on over into the shader that we need to use, the ship greebler. Here's our ship greebler. And you can see here that it says in.uv main text, and what we need to do is make it so that's not what it is. We're going to want to change that in UV main texture to some other method of determining a UV coordinate. Now we could use like vector 3 world position with one of the vector 3 elements chopped off, which is probably going to be what we use. The problem is that I don't really know how to do that without also going and doing a 6 or at least a 3-way texture system where I just chop off one of those elements depending on which element is lowest. I guess that would work. All right, so how do I get things besides? Here's the world position. I think there's a local position as well. I don't remember it. Let's see whether or not I can find it. Input structure, screen position, world position, world normal, world flare, world normal. Well, I think that the vert position is actually already included, right? No. How do I just get it to tell me what the vert position is? I got world position, but I don't really care about that in this case. Wait, I did this before. We like went out of our way to build this. Here it is. So here we go ahead and put the vert normal in because we couldn't get the normals, right? I can do the same thing with the vert position, right? I bet I can. So if we were to take a look here, I think I have to specify that vert, yeah, vert, here it is. So just add that in on the pragma. And we're going to want this to be vert pos equals Float 3 by 3 object to world. We don't want it object to world. We just want it to be v.pos. I don't know what v is. You think it's pos or position or Unity app data full position, I think. Or maybe it is dot vertex. Position is the vertex position. Yeah, so I don't know what dot vertex is. There we are. So that will give us the vert position in the mesh itself, I believe, rather than globally. That's still not great because it doesn't involve the ship's overall position. We'll go ahead and massage that later. For now, we'll just use this as a thing. We can always add in the global position using the method that is specified before, and then we can like set as an override the ship's location. The problem is that doing that will continuously require us to update the ship position to all shaders, all materials rather, in our ship. Sorry, all mesh renderers in our ship. I think that that's actually faster than it might sound, but it's also annoying and stupid, and I hope I don't have to do it. Well, let's try it the way it is now. We'll go ahead and create a new float2 UV equals, I don't know how to do this. Is it called? Defining these is something I'm not used to yet. I haven't looked at the chat window in forever, but I don't think I've got any messages. Oh, I got... Nope, I don't have any. That's fine. Okay, so it's float2, and then the two things that I need it to be. So that's going to be in.vertpos.z and in.vertpos.x. And then here we'll pass it the UV. Oh! Oh, didn't expect that. Unexpected identifier input. What did I screw up? I thought that I copied it. Did I... Is there something else I needed to put here that I didn't actually understand? Do I have to put this after the struct? I said that it was. It said that it was... Oh, hold on. I don't know how to specify this because it's like it's telling me to put in a colon position, but that doesn't make any sense in this situation. So is it position? No, it can't be. That's dumb. Is it SV position? So how do I get the position? It says that it's got the position, but it doesn't tell me what it is. app data full position. Dot vertex. It was dot vertex. After all of that. All right, so we're back. Let's see if we can make some progress. Here you can see what we've got going on here. We've given our texture a more interesting look. But you can see that the coordinate system is not the global coordinate, it's the local coordinate, which means that it repeats erratically depending on the exact rotation and position of the object in question. So for example, this particular mesh will always have the same stripes down the side, even if it is rotated. So if I rotate it, it's going to keep these stripes down the side because it's only using the local coordinates. If I were to greeble it, I would be greebling it on the local space. So how can I make it so that it isn't greebled on local space? Well, one option is I could take the global space and then set the ship location as a parameter. Another option is that I could use the UV mapping to mark how greebled it's supposed to be, which seems like it would be a lot easier. So that's what we're going to do. We're going to use a greebling mechanism on the UV system. So if we go in here, we can go over into our mesh fader and set this up with a UV override as well as a color override. List vector2 UV override. Like so. With this UV cache, we can set up the UV coordinates to be anything we would like. Now, one option here is to make these UV coordinates like actual UV coordinates, but that's not how we're using them. We're using them as a greebledness. So we're going to store one value in y, which is going to be how far along the ship it is. But the other value, I'm not sure what we want to do with that. So right now we'll leave it as 0. We'll add something else into it later. So here we have the overall bounds and the bounds blah, blah, blah. This here, this val, this is going to be our UV coordinate, but we're going to cap it. So val equals mathf.clamp 0, 1, val, no, not 0, 1, val negative 1, 1. There we are. And then we're going to want to have this get put into our new UV coordinate system as well. So UV cache.add new vector2 0 val. We'll figure out what to put in as x after we've thought about it for a while. Down here, we're going to use mesh.set UVs. And we have to specify a channel. I think that our channel is just 0. I'm not entirely sure, though. We have more than one UV channel we can use, so I mean, we can put a crap ton of info into our UVs. Another option is to actually have our UVs have UV values in them. But I actually want to avoid that if I can. It might become necessary in the long run, in which case I'll just switch this over to a secondary system. So here what we've got is these UV values are not the UV values we're using. Instead, the UV values we're using are going to be lerping this. So we're going to say C times equals color lerping, which I think is a float 4 lerp. Do I just say lerp? Oh, yeah, lerp. So it's going to be the texture, the texture, and then the actual UV-ness, which is in dot UV main text dot y and white. We'll call this the ungreebled. And we will make this a value we can take. Main text isn't... Oh, because it's got a capital M. That's fine. I'll spell these things right someday. There we are. So right now it has no difference because the UV coordinates are all quite static. But once I tell this wooden ship to fade, it should greeble only in the back, and you can see that happening. You can see how there's sand texture back here, but up here there's no texturing. See that? That's the sort of thing we're going for. We may make it into a different sort of situation in the long run, but that's the basic idea. We can make this thing quite different. The problem is that we don't actually want to lerp our color. What we would like to do is make other values equal to that. So right now we've got metallic and glossiness as values we can set. What we're going to want to do is multiply those by these values. So times... okay, so we have this here. This here results in a color, which is a fixed 4. So fixed 4 greeble color, or greeble blah. And what we're going to want to do is use different channels of that for multiplying out these things here. But we're going to want to lerp between this and 0. Greeble equals lerp, and then what's 0? Do I have to define it as float 4 or fixed 4? 0, 0, 0. I'm sure that there is a 0 we can use. I don't feel like defining a new fixed 4 for this every single element here, so we'll just use ungreebled color for now. And then we'll use in.uv main text.y. And we're going to just go ahead and set this color up a little bit differently here as 0, 0, 0, 0. We'll work on that later. Right, so now we've got the greeble value, and it's been lerped with main text.y, meaning that it will be somewhere between 0 and 1. Actually, let's go ahead and leave these at 1, 1, 1, 1 after all. I think that's going to be better, because that way it can only be reduced, it can't be increased. So here we're going to multiply this by greeble.x, and this is going to be multiplied, oops, that's supposed to be a multiplication mark. This can be multiplied by greeble.y, and I don't know what we have besides metallic and smoothness. Let's go ahead and quickly look up the surface output standard arguments, which I believe I already have open somewhere. We'll just go ahead and search it anew here. Here we are. Emission, specular, gloss, alpha, normal, and albedo. I don't have any normal modification happening. I may want to modify the normal, but I'm not sure how. Because normally, you use normal map, and normal maps are pretty complicated in terms of already containing a lot of baked data. If I were going to do this, I might be able to just perturb the normal or something similar. Yeah, let's go ahead and try and perturb the normal. O.normal equals lerp. O.normal, and then some perturbed value, O.normal plus, can I get a random value out of this with any speed, or is it going to be like, it's not going to have any speed to it, is it? It's going to be slow as balls if I do something that's actually random. Plus, it's going to like vibrate, which would be very strange. I don't know how to perturb a normal. All right, for now we're going to leave that off. We'll just do emissive, I guess. No, we'll just leave it off. There. Just X and Y for now. Later on, we'll figure out what else we want to do and how. Barf. There we go. So we hit play. And then we tell our ship to fade. All right, and this is what we end up with. Now the problem is that the actual texture we're using is very bright. It's not got a lot of distinctiveness to it. It's largely just a noise field. So what happens if we choose a different map? Because that's just, it's a little too bright for us. Let's go ahead and pick this. It's a normal map, but that's fine for us. We're just looking for something a bit more spectacularly different. There. Just pick some random stuff. Why not? Ooh, I've suddenly gotten really, really hungry. Fatal meshes, please. Okay, so what we should have is something noticeable, but we don't appear to. I don't see any hint that that value ended up making any difference. Let's go ahead and multiply the color by Greeble.z, which should be blue. That should at least make it so we can tell what's going on. Ah, there we are. I guess the metalness and the smoothness aren't a huge... Oh, it's because they're already quite low. Oh, I'm an idiot. Okay. So obviously the problem here is that I'm multiplying by something less than 0, or less than 1, for something that's already very close to 0. I should be moving in the other direction. I should be moving up rather than down. So what we're going to want to do here is multiply by 2 minus Greeble.x and 2 minus Greeble.y. And I don't know if you can hear that, but my next door neighbor has started his weekly party. And so I've got some blooping in the background. Okay, so one of the things I just noticed is we're going to have some real vibration when this arm moves because we're using the world coordinates of the vert. And apparently that is not baked. That's real-time altered based on the exact position. So we're going to have to work with that. But we should be able to get some niceness out of this. Let's go ahead and take out the Greeble Z here. And see whether or not we can get some noticeable smoothness and glossiness. Boom. Okay, so yeah, you can see we've got some streaks happening here, and that's kind of nice. Yeah, see how we got some divots. Obviously, this requires some work. We aren't really being very careful, but you can see how we do have some distinctiveness here. In fact, we got some happy coincidences, and that's good. Now, on the other hand, what we are doing is we are greebling the back end of the ship when the back end of the ship happens to also be the dark side of the ship, which is sort of like it's going to play down the greebling. But what we can do here is let's put this back in and just see how it looks, because obviously it looks dumb here, but how does it look once we've baked it? Yeah, see, that actually doesn't look too bad. The skinned meshes are going to give us a problem either way, though. So with this in mind, you can see that we've got a very, very dark ship. And that's really not what we want. But what we have, I don't know if you can see that rippling. We've got this rippling down the side of our fins. And that's because we're using the world position for something, I think. Or is it just an illusion? Do we not have rippling? I don't see any rippling now. I don't see any rippling. Maybe I was wrong. And there is no rippling? It's just a happy coinkydink. Okay, it doesn't look like there is any rippling, which is good. Because the whole point is there shouldn't be any rippling. Oh, I see what it is. It's the objects behind us, down below us. Let's go ahead and modify the colors that we're using just so that we can get a little bit of a feel for how this is going to look when we're using brighter colors, because this is obviously quite dull. 10 Chaos 1, happy accidents. Yes, it's the Bob Ross of spaceships. Boom. So now when we fade all meshes, we should end up with... So you can see it's still quite dark. The reason for that is because the texture we're using is quite dark in places. If we were to select a different texture that's not as dark, I think that the texture is actually counting as black where it's transparent. So if we pick something that doesn't have that problem, like a Viking shield and axe, I'm not sure why I have this in this project. It still ends up being quite dark. There shouldn't be anything that dark in the Viking shield, and I guess there's a little bit of black, but it's mostly bright. If we pick up something that's really bright, like that sand again, it's still super dark. Look at how dark that gets. So there's something wrong with our calculation, and I think the problem is that our UV is running from -1 to 1 and not from 0 to 1. So let's go ahead and fix that up over here in the mesh fader. This is going to have to be val plus 1 divided by 2 in order to bring it into the acceptable 0 to 1 range. That's not so bad, but it still gets pretty dark, and it really shouldn't. The sand, it really isn't that dark. Is it? I bet it's metallicity. I bet that is the sky there, not actual darkness. Let's go ahead and disable the metallicity modifier here. Just trying to figure out exactly what's going on, you know. And you know what? For the sake of my sanity, let's go ahead and tell this to fade automatically when we hit play. Public void awake, fade all meshes. That's not how you spell it. Nah, that's how you spell it. We have an extra one up here. We'll just get rid of that one so we don't do things twice. It's still quite dark. It's also playing up some of this Z fighting. There was no Z fighting problem before because they were the same exact color. But now for some reason they have different colors to them, and I don't know exactly why that is. Oh, it's because the UV map is a little bit different. I see. You know, I'm gonna have to think about the best way to do this. The greebling is a big issue, and I just don't know the best way to make it work. Because I just realized that it can't work based on the UV of the vert, because that will cause Z fighting, and a big part of my setup right now is that you can overlap stuff without Z fighting because they have the exact same value. So I am going to have to use the world position and update it with a ship. God damn it. And I'm sorry, my voice is gone now. I don't know if you can hear that, but I actually can't keep streaming. Sorry. You won't be able to hear me in 5 minutes. So I'll think about the best way to do this, and on Wednesday I'll see you again and we'll try and finish this up. Sorry that it was a little bit shorter than I thought. I was hoping to get this done today, and that didn't happen. I only got about half done. So I'll see you on Wednesday. I have a week off, so I may stream at other times, and I may stream earlier on Wednesday. It depends on how things go. That's it, and I'll see you around.